So just now I discussed with you modulus of elasticity are of three types. What are the three? Young's modulus, rigidity modulus, bulk modulus. So in these three, first I am concentrating on Young's modulus. Young's modulus. What is Young's modulus? It is defined as ratio of longitudinal stress to longitudinal strain. That is, longitudinal stress to longitudinal strain. Longitudinal stress to longitudinal strain. Now look at it please. For example, this is the body. If I apply the force on this, you know very well, normal force. Normal force per unit area is called stress, known as longitudinal stress. Change in length per original length, that is strain, delta L by L. So now that is FL by A delta L is the Young's modulus. Young's modulus, longitudinal stress by longitudinal strain, F by A, longitudinal stress by strain, delta L by L. So that is FL by A delta L is the Young's modulus. Right. With this, so many applications we will find in the mechanics. Right. For example, applications of Young's modulus. So my request please, first we will think about all the applications of Young's modulus, rigidity modulus, bulk modulus, then Y&K relations. Yeah, please. First one, let us suppose a string of length is L. String of length is L. Area of cross section is A. Is subjected to a mass M. Then they will ask us like this. What is the extension in the wire or elongation in the wire if Young's modulus is Y? Understand please? Wire of length L, area of cross section is A, subjected to a mass M, then it elongates. What is the extension in the wire? Simple please. You know very well, Y equal to FL by A delta L. A simple logic is there. What is the force here? The restoring force or deforming force is nothing but weight, mg. That is mgl by A. E equal to extension equal to mgl by A by. Sometimes the same thing they can put question to you like this. This is first application. Second application they can give you like this. M1 is the mass and M2 is the another mass is attached to the second wire. A simple logical question based on NLM. Then they will ask like this. Young's modulus of this wire, let it be Y1. Length is L1. Area is A1. Similarly, length of this wire is L2. Area of cross section is A2. Young's modulus is Y2. They will ask us like this. What is extension produced in the upper wire? Extension produced in the second wire. They will ask you like this. Extension produced in the upper wire is, we have to think about this free body diagram. M1G downwards, tension upwards, and lower part tension is also downwards, that it is, let it be T1, T2. If I draw the free body diagram for second body, M2G downwards, tension upwards, T2. It is under equilibrium. It is under equilibrium. Then you can understand like this. T2 equal to what? M2G. They will ask us like this. Young's modulus or extension produced in the upper wire M1 plus M2, clear please, M1G plus M2G into L by AY, but first wire A1 by 1. Similarly, they can ask you like this, extension produced in the second wire. How to get this? Extension produced in the second wire is simple, tension in that wire, that is M2GL by AY2 is the extension produced in the wire. This is equilibrium conditions of two objects attached to the system. Right. Once again please. If the object is subjected to weight M, then extension produced in the wire is MGL by AY. Nothing is there, F is replaced by MG. In this case, two bodies are attached, different materials Y1, Y2, length L1, L2, area A1, A2. They will ask us like this, extension produced in the first wire. Free body diagram of first wire, you can understand M1, that is M1G downwards, T2 downwards, T1 upwards. Second free body diagram is T2 upwards, M2G downwards, then I think so you can understand M2G equal to T2. Extension produced in the upper wire is M1 plus M2 into GL1 by AY. Similarly, extension produced in the wire is M2GL by AY. 2 is the extension produced in the second wire. Please. Next, we will think about further extension applications of Young's modulus. Next, third application is like this. Imagine this is the string of length is L. Having area of cross section is A. One end is in my hand, another end is connected to a mass M. Another end is connected to a mass M. And now this string is set into horizontal circle. Very important thing. Horizontal circle. Yeah, please. Horizontal circle means it is free from gravity. It is free from gravity. Yeah, then you can understand, once the object is rotating in horizontal circle, you are having two types of forces. One, tension in the string is towards the rigid support, that is acts as a centripetal force. There should be some other force which should be balanced, is nothing but what? mv square by r. mv square by r. Now, this is a centrifugal force. They will ask you like this, what is the extension produced in the wire? Yeah, very good. Y equal to, look at it please, 3 applications, I am using the same condition. Y equal to FL by A delta L. What is my aim here? Extension, they can put question to you. That is FL by AY. Here F is nothing but what? Tension. Tension equal to what? TL by AY. T is nothing but what? mv square by r. This is the condition. mv square by r is nothing but what? Length of the wire into extension, I am taking it as almost negligible, into L by AY. So LL gets cancelled. mv square by AY represents the extension produced in the horizontal circle. This is a third application. Yeah, once again come to the conclusion of like this please. Student will get doubt like this, sir, if any object is immersed in water, its weight decreases. Its weight decreases. Then what about its extension? You may get it out like this. Look at it please. It's a beautiful application with hydrostatics. That is, if an object is attached to the weight M, like this, then you know very well, first example of mine is like this. MGL by AY is the extension. So this is immersed in water. Immersed in water. Completely immersed in water. Then they can put question like this. What is extension in the wire? That is free body diagram. If I draw it, FBD, mg weight downwards, next tension upwards. Yeah, clear? You know very well that it is immersed in liquid. It is subjected to a buoyancy force. What is that buoyancy? V rho c is the buoyancy. V rho c, take care please. Here V is the volume of immersed portion, that is completely immersed. Now that is, I think so you can understand. T equal to mg minus V rho c. Understand please? T plus V rho c equal to mg. T plus V rho c equal to mg. T equal to what? mg minus V rho c. Then I think so you can understand. If I take mg common, 1 minus V rho by mass. Mass is what? Density into volume. Volume gets cancelled. Then that is mg into 1 minus rho by d. mg into 1 minus rho by d. That means you understand, tension decreases, then automatically extension decreases. E dash equal to mg into 1 minus rho by d into L by Ay. Please, from this and this equation, you can say very easily extension E dash equal to E into 1 minus rho by d. Extension E dash equal to E into 1 minus rho by d. So what is the conclusion is, in water extension decreases. How much? 1 minus rho by d. I think so you know about this. D by rho is called specific gravity or relative density. D by rho is called specific gravity or relative density. That I can write like this. E dash equal to E into 1 minus 1 by Sg. This is the specific gravity conditions. This is about immersed in liquid. When it is immersed in liquid completely, this is the concept. Sometimes the paper setter was tricky. They want to create the question like this. Concerned to same model, but it is little bit tricky. Instead of completely submerged, they will give us half of is submerged in water. Then how to do the problem? This is one time given in the old JEE mains questions. Half of is submerged in water. Then how to calculate the extension in the wire? Please look at here. Same thing, free body diagram you have to take care. mg downwards, yeah, correct. Tension upwards, right? And buoyancy. Now you have to take care please. Buoyancy. Liquid density, let it be rho. Solid body density d. But here is not completely submerged. Half is submerged. V by 2 into rho into c. Previous I didn't get like that. Please take care that it is volume is taken completely submerged. Here is what? Half submerged. Then T equal to mg minus V by 2 rho c. I think so you can do it. It's not a big problem to you. mg taken common. Remaining thing you can do it. 1 minus rho by 2d is the tension. Then extension E dash equal to, or E double dash, new concept, E double dash equal to mg into 1 minus rho by 2d of L by Ay is the extension in the half submerged. Sometimes the same concept they can put question like this, extension of this. Think about it. Sometimes they can put question like this. Sir, half is one liquid, remaining half is air. For example, two sides they filled with liquid of different shapes, different densities like this. Half is in rho 1 h by 2. Half it is in another liquid of density rho 2. Then how to solve the extension in the problem? Same thing please, only the difference is like this. Tension is upwards, mg downwards. Yeah, please, instead of taking V rho c, here you are having two liquids, different densities, two different liquids. That is V by 2 rho 1 z half, for example, plus V by 2 another liquid of rho c. You may get it out like this, 1/3 or 1/4, anything you can do it based on this. Now that is T equal to mg, I taken common direct please, 1 minus rho 1 plus rho 2 of V by 2 by m. I think so you can understand please. Then that is mg into 1 minus rho 1 plus rho 2 of 2d is the extension, tension in the wire. Extension I required, please, extension is nothing is that, simple, substitute T in the given equation. mg into 1 minus rho 1 plus rho 2 of 2d into L by Ay is the extension. This is difficult to model, they feel the students in the paper setting. This is about immersed portions, first completely submerged, half submerged, two different liquids, mixing non-mixable liquids, densities like this we have to do. Next we will think about another application, that is conical pendulum. Conical pendulum is a beautiful application. Conical pendulum means just like, imagine like this, it is a bob and performing horizontal circle like this, horizontal circle like this. Now look at it please. A string of length L, area of cross section is A, having Young's modulus Y, forming the horizontal circle like this please. Horizontal circle. They can ask us like this, what is the extension in the wire? Let us suppose, you know very well, mg, free body diagram. Tension towards the rigid support. They will ask us like this, what is the extension produced in the wire? How to calculate this? Same logic, same thing, but here is concerned to tension like this. This is theta. Tension is a vector quantity which makes some angle, can be resolved into two components, that is T cos theta, T sin theta. T cos theta, T sin theta. T sin theta is balanced by centrifugal force mr omega square. R is the radius of the circle. R is the radius of the circle, take care. L is the length of the string. Now look at it please. It is under equilibrium. Equilibrium means you can do like this. T cos theta equal to mg. T equal to what please? mg by cos theta. T equal to mg. T cos theta equal to mg. T equal to mg by cos theta. Then they can ask us like this, extension E equal to FL by AY. Same concept. Instead of F, what I would write? T. MGL by AY into cos theta is the extension produced in the wire. They can put question like this. If they give theta, well and good. If they won't give theta, how to solve the problem? Right. Then you required, if theta is not given, how to solve the problem? That is T sin theta equal to mr omega square, T cos theta equal to mg. You know from your trigonometry, trigo. Squaring and adding the terms, sin theta can eliminated, that is t square sin square theta plus cos square theta, please squaring and adding the terms, that is mg plus mr omega square whole square, squaring and adding the terms, t equal to square root of mg whole square plus mr omega square whole square. If I know the tension, I can calculate extension from this if they won't give theta. This is one of the application of conical pendulum. Number of times they are giving in the examination paper. Simple, nothing is there. Just resolve the vector into components. T cos theta, t sin theta. T cos theta is balanced by weight. T sin theta is balanced by mr omega square. Bas enough. T cos theta equal to mg. T equal to mg by cos theta. They are asking us what? Extension. E equal to FL by AY. F is what? That is nothing but your tension. Substitute here. MGL by AY cos theta is the extension. Here I got extension, please. If they give theta, I can do it. If they don't give theta, how to approach the problem? If the theta is not given, then approach the problem by eliminating theta. T cos theta mg, t sin theta mr omega square I taken like this. Squaring and adding the terms, I got like this tension. Substitute here, you will get the extension. Okay. Next, we will think about further application. They put question like this. A person is hanged to a bar or like that. There is some extension in the person. That is not permanent. There is extension is there but not permanent. Look at it, please. Let us suppose this is the wire. Instead of person, I am hanging the bar. Previous what I said with you, massless wire. Now it is having mass. Length is L and that of Young's modulus is Y. They can ask us like this. What is the extension produced in the string because of its own weight? Understand, please? What is the extension produced in the wire because of its own weight? How to do this problem? Right, please. This is called as a free end. Free end tension is 0. At the rigid support, tension is maxima. That's why when a person is hanged to the pole, he get pain at the shoulders because his own weight is maximum at the hands. Right. Like that, free end tension is 0. At the rigid support, tension is maximum. Student, you can understand very clearly. Here is 0, here is maxima, means tension is varying from point to point. Then how to solve this type of problem? Right, look at it, please. Consider a small element in the string of dx. From the free end, let it be x. You may get it out like this. Sir, why you are considering from the free end? Free end tension is 0, starting from 0. And that's why I taken the small element x dx. Very simple. L length mass is capital M. L length mass is capital M. Per unit length M by L. This we call it as linear density. And mass of the element I want to calculate. Mass of dx is equal to m by L into dx is the mass of the element. Then I think so you can understand what is the extension in the element. Let it be dE. You know very well, please, what is our basic idea? Extension equal to FL by AY is the extension formula. This is the basic concept. From that data, dE equal to m by L dx is the mass of that dx element into G is the weight tension into length. Length is what? X from the free end by what it is please? Ay. A and y are constants. Integrating on both the sides. Then I am going to get like this 0 to L extension limits 0 to L and finally is 0 to E. Then I am going to get like this, look at it please, E, constants bring it out, M by L constant, G is also constant by AY into X dx. Student, I think so you know very well about integration of X dx. Power 1 is there. Integral x to the power of n dx equal to x power n plus 1 by n plus 1. My request please. Integral x to the power of n dx is x power n plus 1 by n plus 1. Now look at it please. Here you are having power 1, that is 1 plus 1 by 1 plus 1, that is mgl by ay x square by 2 0 to L limits. That I think so you can do it, L square by 2. Then I am going to get mg, L square and L gets cancelled. Direct I am going to write like this, mgl by 2ay. This is very very important topic for JEE mains. I think so one time they given in the old papers. Extension produced in the wire due to its own weight. Don't forget it. Maximum students they write mgl by ay. It's wrong. Mgl by 2ay is the extension produced in the wire due to its own weight.